Hello and welcome back to Math 050. This is a section of notes over section 9.3, and we're going to be doing slope and applications. So what we're going to do is we're going to be able to given the coordinates of 2 points on a line, we're going to find the slope of the line if it exists. We're going to find the slope of a line from an equation, and we're going to find the slope rate of change of an applied problem involving slope. So with slope, what this is, we got a couple different definitions. Basically what this is this is your rate of change. Okay, and we've talked about this a little bit in chapter 4. And some examples of rate of change would be like miles per hour, cost per gallon. Okay, and basically what it means is the change in y over your change in x. Okay, and some people often refer to that as rise over run. Okay, but basically what I want to talk about with slope when we're talking about lines is a measure of steepness. Okay, and that's how often why we call when we go skiing, let's go hit the slopes. Okay, if you think of a blue run or a green runs when you go skiing is not as steep, not that steep. Okay, depending on where you go, not that steep. Okay, blue runs, those are medium steep level. Okay, medium steepness. And then when you have your blacks, those are pretty steep slopes. Okay, those are steep slopes. Okay, and that's kind of the idea. It's a measure of steepness. And when we do this, we do this with the change of y over the change in x, the rise over run. So what I want to do to calculate the slope, and what I'm going to do is just draw a couple of, just draw a line here real quick. Okay, what I'm going to do is I'm going to start with this point, 2, 1, okay, and then I'm going to plot the point, let's do 5, 3. Okay, so I'm going to draw a line between these 2 points. So once I put this line in there, what I notice is that my line has a steepness to it, okay? And how I calculate that is and what I usually do from going from one point to the next, I draw a triangle that connects from one point to the next, okay? And so what I do is I would call this, this is my change in y here, okay? And this is my change in x, okay? And we want to know, what's the distance of this triangle, and the change in y is a distance of 2. Okay, the change in x would be a distance of 3. So if you wanted to talk about your slope, and we would do, when we do this, we use m means slope. Okay, that's our variable for slope. So let me write that out. Variable for slope. M would be equal to, say, the rise, which is 2, and the run, which is 3. Change in y is 2, the run is 3. And what this is this is a measure of steepness. Okay? So once I have these points, or have that kind of information there, it allows me to, measure the slope. And what's cool is I can use any point to do this. And if I go from, one point to the next, I go up 2 over 3. Same thing here. I go up 2 over 3. I go up 2 over 3 to my next point. All right. So we have this thing, and it's called your constant rate of change. Okay. Now, if I wanted to calculate the slope, okay, and, we've already kind of established that we go up 2 over 3. What I want to talk about is using these points to do that, okay? And this is the point Let me zoom in here. This is the point 2, 1, and this is the point 5, 3. Okay? Now, what I want to think about here is when I'm talking about my change in x values, okay, my x values, this is a 2, and this is a 5. Okay? And the other thing I've got are my y values here, which this is a 1, and this is a 3. So my question is, using the numbers, 3 and 1, how do I get 2 out of using those? Okay, and what I would really do here is I would do my slope m would be equal to taking this y value 3 minus this y value 1, and then dividing that by the difference of 5 and 2. Okay, so I can get the number 3 by subtracting 2 from 5. Okay, so I would write this as 5 minus 2. Okay, so when you have this, when I go from this, this is from the points, 1, 2, and 5, 3. All right. So now what I want to do is I want to come up with a general formula to calculate the slope, okay? And what I'm going to do is what I realize here is that, what I have here is this is really an x value and a y value from 1 and 2. And the same thing with 5 and 3. This is an x value and this is a y value. Now what I'm going to do is I need to name these points. This is my first point, okay? First point, and this is my second point. All right, so with my first point, I'm going to call this x sub 1 and y sub 1. And for my second point, I'm going to call this x sub 2 and y sub 2. All right, so my general formula that I would come up with, if I do, say, and this is wrong, this should be the point, not 1, 2, but the point 2, 1, okay? Using the numbers 3 and 1, what I'd really come up with is doing the value y sub 2 minus y sub 1. So my general formula here for my slope would be y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Now, this is a general formula to calculate the slope given 2 points. So I can calculate slope given 2 points. All right, so this is how I come up with that. That's how I come up with that, that general formula by using that idea. But what I want to do is do the same thing with these points here. So I'm going to apply this idea. So this is very important. This is probably something we want to memorize or do something with. So let's go ahead and jump in here, and let's go ahead and plot these points. For -4, 3, okay, let's plot that point here, and then the point 2, -6. 1, 2, 3. Okay, and I'm going to connect the line with those. All right, so once I put that line in there, what I want to do is draw a triangle to show my change in y, okay, and that's going to be my change in y, and then this distance here is going to be my change in x, okay? Now, the distance for that y, so when I do that, that's that line, and so I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. Change in y, and this is going to be equal to -9, actually, and we'll talk about why that's negative here in a second. And then we're going to go this way, so 1, 2, 3, 4, 5, 6. Okay, so this is going to give me 6. So if I were to talk about my slope here, okay, m would be equal to -9 divided by 6, which would end up giving me -3/2 after I simplify that, okay? Now, using my slope formula, which we have up here, okay, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. What I'm going to do is I'm going to label these points here. And I'm going to label them as x sub 1, y sub 1, x sub 2, y sub 2. All right, and so when I fill this out for my slope, m, I'm going to do y sub 2, which is negative 6, minus 3, divided by x sub 2, which is 2, minus, and then negative 4. Okay, so we always subtract even if we have negatives in there. And what that's going to give us is going to give us negative 9 over 2 plus 4, which is actually 6. So negative 9 over 6, and so our slope is just going to be negative 3 halves. Okay, and what you could also think about here is going from one point to the next. If I draw this here, if I go to this point, if I go down 3 over 2, I'm back at my line. Down 3 over 2, and I'm back at my line. Okay, and that's the idea. Now, the reason why we have slopes that are negative and positive, and I'm going to do this up here. So we have types of slopes. We have 4 types of slopes. Okay, and I always draw this picture. I draw it like this. This means a positive slope. This means a negative slope. If we're going straight across, this is 0 slope. Okay, and if we go straight up, this is undefined. Okay, all right, so because my graph, my line was going in this direction, that's going to give me a negative slope. Okay, if it's going in this direction, it's a positive slope. Okay, if it's horizontal line, 0 slope. Vertical line, undefined slope. Okay, all right, so let's look at the next one. All right, and let's just go ahead and graph these points here. So I've got the point negative 2, 3, right here. Okay, and the point 3, 5. So 1, 2, 3, 1, 2, 3, 4, 5. Okay, so from here, let's go ahead and draw my line. All right, and so there's my line. And what I want to do is come in here and do the same thing. Okay, do my rise, and then do my run. Okay, and remember to call this my change in y is equal to 2, and then my change in x is equal to 5. Okay, and I can do the same thing, here. I can go up 2 over 5 to get to the next point. I could also go down 2 to the left 5 to get to that point. Okay, so it doesn't really matter. All right, so I know this. I know that my slope is going to be a positive 2/5. Now, the other reason I know that is going in this direction. Okay, it means it's going to be positive. All right, so let's go ahead and use these points here to figure that out. All right, and so let's call this x sub 1, y sub 1, x sub 2, y sub 2. So my slope m, using my formula, I'm going to do 5 minus 3 over 3 minus negative 2. Okay, so 5 minus 3 is going to give me 2. Okay, and then 3 minus negative 2 is really 3 plus 2, and that's going to give me 5. So my slope is equal to 2/5. Okay. Now, the cool thing is about this is that, it's pretty easy to do this with a graph. So if you have some graph paper, I recommend, printing some out. Otherwise, you can always use your formula. So you got 2 different methods of doing this. Okay, so now what I want to do is find my slope of a line from an equation. So all of these equations, if it's, and what I'm looking for is this. The form y equals mx plus b. Okay, and what this means is that the slope is the number in front of the x. Okay, and that's always going to be the case. So what I want to do, looking at all these different equations, I want to identify the slope from this equation. So what I notice is this, all right? If I've got y equals 4x plus 11, looking at y equals mx plus b, okay, the number that's in front of the x is my slope. The number that's in front of my x here is 4. So my slope, m, is equal to 4. And that's it, and that's all we're doing. Okay, on this next one, what I've got is using y equals mx plus b, I see that, my slope is the number in front of the x. The number in front of the x here is negative 17. So my slope here is negative 17. All right? Okay, on the next one, this one's a little bit tricky. Thinking of y equals mx plus b. All right, when I look at this, I just have a negative sign out there. Now, if I were to rewrite this, I'd rewrite this and write negative 1 times x and then plus 1/2. And so my slope m is equal to negative 1. All right? And on the last one, okay, just looking at the number in front of the x, m is equal to 2/3. All right? And so, there's a couple different ways of doing it. If you have the equation of these lines, and all these lines have their own equation, and we'll look on the next section on how to find those equations. But, given 2 points, you can calculate the slope. Simply having the equation of the line, we can find the slope as well. Now, what if we've got equations in standard form, where we just have, x and y on the same side of the equal sign? What I want to do, okay, is solve these equations for y. So if I solve for y, okay, I can find the slope. All right, and so what I'm going to do is I'm going to subtract, I'm going to get y by itself. So I'm going to move the 2x over to the other side, so I'm going to subtract 2x from both sides. Okay, my next step of the equation is going to be 3y is equal to negative 2x plus 7. Okay, and then what I'd want to do to get y by itself, I'd want to divide everything by 3. Okay, so I'm going to divide this by 3, divide this by 3, and this by 3. So what I get, these 3's divide out. I get y is equal to negative 2/3 x plus 7/3. All right, now this is in the form of y equals mx plus b. Okay, and I'm just identifying the number that's in front of the x, okay, which is negative 2/3. So my slope here, m, is equal to negative 2/3, and that's all I'm doing. Okay, now over here, okay, let's solve this equation for y. I'm going to subtract both sides by 5x minus 5x. Okay, I'm going to get negative 4y is equal to negative 5x and then plus 8. I'm going to divide everything by negative 4, divide by negative 4, divide by negative 4. Okay, what happens is that my 4's divide out, and so I'm left with y is equal to negative 5 divided by negative 4, which is actually going to give me positive 5/4 x and then minus 2. 8 divided by negative 4 is 2. So now I'm looking for the number in front of the x, and that's my slope. M is equal to 5/4. And that's my answer. All right, let's look at slopes of lines, of horizontal and vertical lines. So what I want to do is just graph the equation y equals 5. So what I want to do is look at my slope here. Well, let's graph this line. So 1, 2, 3, 4, 5. Here's my y-intercept of 5. Okay. And we have a horizontal line this way. Okay, so what I want to look at is this. Y is equal to what times x and then plus 5. And that's going to be 0. Okay. That's one way to look at it, to identify that your slope is 0. But let's do the slope formula on a couple of these points. Okay, let's do the point 3, 5, and then let's do the point negative 2, 5. And so I basically just chose those points. But if I were to find the slope between them, okay, here's x sub 1, here's y sub 1, here's x sub 2, and y sub 2. My slope m is going to be equal to 5 minus 3 divided by, 5 minus 5, not 5 minus 3. 5 minus 5 over 3 minus negative 2. So 3 minus negative 2. And my slope m is going to give me 0 over positive 5. And my slope m, 0 divided by 5, is just going to be 0. And that's my slope there. All right. If I look at vertical lines, okay, using the line x equals negative 4, okay, I'm going to come over here and find negative 4. 2, 3, 4. All right, and this is a vertical line through negative 4. All right, and so what I do is I'm just going to pick a point. This is going to be the point negative 4, 3. and this is going to be the point negative 4, 2, negative 2. And so if I find my slope, this is x1, y1, x2, y2, using my slope formula, I'm going to do negative 2 minus 3 over negative 4 minus negative 4. Okay, and what's going to happen is I'm going to get negative 5 divided by negative 4 plus 4. This is going to give me negative 5 over 0. Now, the issue here is that I can't divide by 0. Okay, this is undefined. So, therefore, my slope is undefined. Okay, and that's it. All right, so that's it. That's kind of what we're doing here on how to find slope. Okay, it's a very useful tool. It's something that you guys will use from every math class here on out. So this is really an important section. And when we do our homework, I want you guys to go ahead and skip 49 through 60 all. I just want you guys to go to number 47, and that's it. So hope you enjoyed this video. We'll talk to you soon. Thanks a lot. Bye.